Properties of electric charge. Now there are 5 important properties of electric charge. Number 1 is that unlike charges, they attract one another, and like charges, they repel one another. So if you have a negative and a positive, they will be attracted to one another, and if you have a positive and a positive, they will repel. Negative and a negative, they will repel. And the second property is that the charge of an electron is negative in nature and is equal in magnitude to 1.6 into 10 to the power minus 19 coulomb. This is known as the elementary charge. Similarly, the charge of proton has the same magnitude, which is equal to 1.6 into 10 to the power minus 19 coulomb, which is called the elementary charge, denoted by the small letter e, and the charge of the proton is positive in nature. So that is the second property. Now the third property is that charge is additive in nature, and the fourth property is that charge is quantized, and the fifth property is that charge of an isolated system always is conserved or always remains constant. Now, to understand these 3 properties of electric charge, what I will do is that I will take a plastic pen, and with this, actually this plastic pen is neutral, like most material and most matter are. So this plastic pen is neutral at first, and if I take this plastic pen and I rub it to my hair, and as I rub it to my hair, after I rub it to my hair, and I bring it close to a piece of paper, what happens is that the piece of paper will tend to stick to this plastic pen, and as you can see, this piece of paper is attracting towards this plastic pen. Okay, and it's like dancing around this plastic pen. So why this happen? So if you take a plastic pen, and if I rub this plastic pen to my hair, now the hair is also neutral at first, and as I rub this plastic pen to my hair, what happens is that there's a friction between the pen and the hair. And this friction creates an energy, and this energy is used up by the electron in my hair to jump to the plastic pen. So the electron, in other words, the electron is being transferred from my hair to the plastic pen, and the plastic pen now has excess of electrons, and my hair has a deficiency of electrons. So if the plastic pen has an excess of electron, too much of electron, then it is said to be negatively charged. And my hair, since it has a deficiency of electron, or it has lost electrons, then it is said to be positively charged because it has more protons in it. So any object which gains electrons, they are said to be negatively charged, and any object which loses electron, they are said to be positively charged. For example, the pen here is negatively charged because it gains electron, and my hair it's positively charged since it loses electrons. So now if I take this negatively charged pen and I bring it close to my, close to the piece of paper. Now again, the piece of paper here is also neutral at first. And as I bring the negatively charged pen to this piece of paper, the piece of paper is neutral, so what happens is that the electrons in this piece of paper will be repelled by this negative charged pen. Now since negative and negative, they are there's a force of repulsion between them. Like charges, they repel one another. So the negative electrons in the paper, they are repelled to the other side. And the positive charge, which are the protons in the paper, will be attracted towards this negative charge pen, since the negative and positive, they attract one another. So as I bring this pen closer to the piece of paper, what happens is that since there's a force of attraction between the negative charge pen and the positive charge protons in the piece of paper at the other side, if this force of attraction will be stronger than the force of repulsion, since the distance between this negative charge and the electrons in the paper, they are large, and the distance between the negative charge in the plastic pen and the positive charge in the paper, which are the protons, they are smaller. So the force of attraction is much more stronger than the force of repulsion. So this piece of paper will tend to stick or tend to attract towards this plastic pen. Okay, so that is what happens when you rub this plastic pen to your hair and you bring it close to a piece of paper. It will stick towards this plastic pen. And you can perform this activity with plastic comb also. You can perform this activity with a plastic scale, like most of us has done during our school times, and we call it magic. But it's not magic, it's science and it's physics. So from this activity, we shall learn and understand about these three properties of electric charge. Number three is that the electric charge is additive in nature. So if we have rubbed this pen to the hair, as I've told you before, the pen will be negatively charged and the hair will be positively charged. Now the third property says that charge is additive in nature, which means that the charge of an object, the charge in an object, they can be added. Or a charge in an object is equal to the sum of all of the algebraic sum of all of the charges which are distributed in that object. So if we take the plastic pen, here we have electrons distributed on the surface of this plastic pen. So the amount of charge here, say, is small q, and this small q will be equal to q1 plus q2 plus q3 plus q4. Since we have four charges on this, say we have four charges on the plastic pen, and you know that the charge of the electron is equal to minus E, and the E is the elementary charge. So here q1, q2, q3, q4, they are all equal to minus E. So we have minus E here, then we have plus again minus E, and plus minus E, plus minus E, and what you'll get is minus 4E. So the charge of this plastic pen, small q, is equal to minus 4E, and this E is equal to 1.6 into 10 to the power minus 19 coulomb. Similarly with the hair also, what we have is the charge on the hair will be equal to q dash, say, and this q dash again will be equal to q1 plus q2 plus q3 plus q4. And what is the charge of the proton? The charge of the proton, which is the positive charge on this hair, is equal to E, plus E. So we have q dash to be equal to plus E, then again plus E, plus E, plus E. So the total charge on the hair is equal to plus 4 and that is Q dash is equal to plus 4E. So this is the third property of charge, that charge is additive in nature. So the amount of charge in the object is equal to the algebraic sum of all the charges distributed in that object. Again here, for example, let us take this system. We select this system, which is a plastic pen and a hair. Now again here, what's the charge on the pen? Minus 4E. Charge on the hair plus 4E. Now the charge on this system, which I've selected, the pen and hair, is equal to, say, Q plus Q dash. Okay, so the charge on this, the total charge on the system will be equal to, since Q is equal to minus 4E, so we have minus 4E, and Q dash is equal to plus 4E, so we have plus 4E. And so the charge on the system now will be equal to 0. Minus and plus will be equal to 0. So if you are adding the charges, you'll have to take into account the nature of the charges, whether they are negative or positive. Okay, so you have to keep the minus sign and the positive sign also. So that is additive nature of a charge. Now we come to quantization of charge. Again, we shall take the same example of the same activity. So according to quantization of charge, it says that the charge of an object is equal to some integral multiple of the elementary charge E. And the formula, mathematical formula, is Q is equal to plus minus N E. This N is an integer, and it is equal to 1, 2, 3, 4, 5, 6, 4, 5, like that. And E is the elementary charge, is equal to 1.6 into 10 to the power minus 19 coulomb. So this is quantization of charge. It gives this charge of an object is always equal to some integral multiple of the elementary charge E. And this n is an integer, it cannot be a fraction. So the charge of an object cannot be half of that charge of the elementary charge. Okay, it cannot be a fraction of this E. Now here the letter n, or the integer n, this gives you the number of electrons gained or lost by the object. If the electron, I've told you before, if the electron gains, if the object gains electrons, then that object will be negatively charged. And if the object loses electrons, so that object will be positively charged. And this n gives you the number of electron lose or gain, or the number of electron which is transferred from one object to another. So here, if your object gains electron, then it is said to be negative charge. For example, this comb, see here it gains 4 electrons. So how many electrons it gains? 4 electrons. So the charge on this plastic comb will be denoted by, say, capital Q, and this is equal to 4E. And since it gains electron, it will be negative charge. So we have Q to be equal to minus 4E. And again, if you take the hair here, since the hair loses electrons, how many electrons it lost? 4 electrons. So the charge on this hair, say Q dash, this is equal to 4E, that is the magnitude, and since it loses electrons, you'll have to put a positive sign here. So here the charge of this hair will be equal to plus 4E, and charge of the plastic pen will be equal to minus 4E. So So this is quantization of charge. It gives you the amount of charge in which an object has, and it is always some integral of the multiple of the elementary charge. And the positive and the negative sign here indicates that if it loses electrons, then it is positive, like the hair, and if it gains electrons, the object will be negatively charged, like the plastic pen. Alright, so that is quantization of charge. And remember that this n, it cannot be a fraction. It has always to be equal to integer 1, 2, 3, 4, 5, like that. A positive integer, not negative integer. Now we come to the last property of charge. That is the law of conservation of charge. That charge of an isolated system is always conserved. Again, we shall take the same example here and same activity here. And we select the system, which is the pen and the hair. So we select the system. This is the system, pen and the hair. So now before rubbing this pen to our hair, both the pen and the hair, they are electrically neutral. Right, so both the pen and the hair, they are electrically neutral. So what is the charge? What is the total charge of the system? If both are neutral, then the total charge of the system is equal to 0. So this is the charge of the system, which is the pen and the hair, before rubbing the pen to the hair, is equal to 0. Alright, now if we rub the pen to the hair, then what will happen is that there is a transfer of electrons, making the pen negatively charged. How many electrons? Let's say 4 again. And the hair will be positively charged because you lose electrons. Now, using the additive nature of charge or quantization of charge, we can find the amount of charge in which the plastic pen has and the amount of charge in which the hair has. So here, the plastic pen, using quantization of charge, has a charge which is equal to minus 4e, and the hair has a charge which is equal to plus 4e. Right, and again we use this additive nature of charge, that the charge of the system, the net charge of the system can be found out by adding these two charges, minus 4e and plus 4e, the charge on the plastic pen and the charge on the hair. So here the net charge of the total charge will be equal to this plus or minus 4e, then plus 4e. And again here minus 4e plus 4e, this will give you 0. So the charge of the system after rubbing is also equal to 0. So this is the law of conservation of charge. It says that charge can neither be created nor destroyed. It can only be transferred from one object to another. So the charge of the isolated system is always constant. As you can see here in the example, even though the pen is negatively charged and the hair is positively charged, the net charge is always equal to 0. Okay, so these negative charge here on the pen, they are not created. They are being transferred from the hair to the plastic pen. And this positive charge here on the hair is also not created just like that. So it's because the electrons being transferred from the hair to the plastic pen. So that is the fifth property, which is the conservation law of charge, that the net charge, the total charge of an isolated system, is always conserved or always constant, like in this case, always 0.